Today, we're going to pull back the curtain on a modern industrial process. We're going to see the invisible architecture that actually runs the whole show. The data, the algorithms, and the cryptographic rules that govern every single decision. This is the story of how one simple piece of data becomes an unchangeable legal fact.
So that really brings us to the core question, right? How do you take something as basic as a photo, just snapped on a phone, and turn it into a cryptographically sealed, legally binding certificate that could actually stand up in court? Well, that's the journey we're about to go on.
All right, so here's our roadmap. We're going to break this down into 5 key stages. We'll kick things off with how the data first gets into the system. Then we'll look at the processing challenge right there on the device itself. After that, we'll see how it all gets validated in the cloud, watch the automated legal action it triggers, and then, for the grand finale, see how the entire process gets locked into a permanent record. First up, the phantom dispatch. Now, this is where the physical world smacks right into the digital system. It's also where human dispatchers have been, well, they've been taken right out of the picture. And believe it or not, it all kicks off with a simple text message. So, picture this. A contractor's out on a job site. They snap a photo of a pile of wood and just send it over WhatsApp to this number. That one simple action, it kicks off the entire automated workflow. That message hits a Twilio Cloud PBX, which is basically a fancy cloud-based phone system, and that acts as the system's digital front door. The second that photo arrives, an AI gets to work extracting key variables and packaging them up for a calculation. As you can see, it identifies the bin's volume, it applies a very specific density constant for this kind of wood, and then it uses a multiplier to account for all that empty space between the logs. These are the core ingredients for figuring out the weight. And this just perfectly illustrates the core math behind it all. The system is using a strict physical mass formula to translate a flat, two-dimensional image into a three-dimensional weight estimate. It's just pure mathematics, converting volume and density into a really precise kilogram value. Now, if that calculation for a 14-yard bin comes out to more than 4,000 kilograms, the system instantly throws up a flag. And this isn't an error, not at all. It's a built-in safety check for something they call the sponge effect. All that extra hidden weight you get from waterlogged wood. The system is already anticipating reality before a single truck has even started its engine. Okay, so now we're moving from the cloud to the device out in the field, and this is where things get really interesting. The system faces this fundamental conflict. You need near-instant analysis, but you absolutely cannot sacrifice accuracy, especially when safety is on the line. It's a classic battle of speed versus safety. To solve that speed problem, the system uses a really clever technique called int8 quantization. Think of it like this. You've got this huge, heavy, super smart AI vision model, but it's too big to run quickly on a phone. So you compress it, you shrink it way down, and that lets it run lightning fast. We're talking under 2 seconds, directly on a Google Pixel's tensor chip, even if you've got a weak cell signal. Now, what's fascinating is that this decision wasn't easy. It created a major internal debate. You had one side arguing for speed, saying, hey, if a contractor has to wait 10 seconds for a loading screen, they're just not going to use the app. But then you had this powerful counter-argument. Wait a minute, are we sacrificing the precision we need to detect invisible hazards like arsenic just to save a few seconds? That's not a trade-off, that's negligence. It's a classic engineering dilemma. So how do you solve it? Well, the solution is just incredibly elegant. It's called a multimodal override. The system is literally designed to distrust its own eyes. It knows that visual data can be tricky, it can be misleading, so it uses a totally different sense, hearing, to act as a check and balance. Let me walk you through how this actually works. So the visual AI looks at some old weathered wood and says with 99% confidence, yep, that's clean pine. But then the driver records a quick voice note saying he's just finished tearing down an old deck. That's the trigger. The onboard Gemini Nano model catches that specific word. It immediately recognizes the conflict between what it sees and what it hears, and boom, system override. The audio overrules the visual, and that load is immediately flagged for a high-risk, mandatory X-ray screening. All right, so once that data leaves the device and gets beamed up to the cloud, the real interrogation begins. This is where the system's initial findings are put under a microscope and checked against a huge database of ground truth info, and most importantly, against the law itself. Back at the facility, specialized X-ray fluorescence sensors are scanning the material and are looking for the atomic signature of heavy metals. Now, this isn't a guess. This is hard science. If the arsenic concentration is over 2.5 milligrams per liter, it has officially crossed the legal limit. End of story. And the moment an anomaly like that is detected, the system needs to find a match in its massive library of known contaminants, and it needs to do it instantly. By using Google's Alloy DBI with something called a scan index, it can run these super complex vector searches up to 10 times faster than older traditional database methods. You see, speed isn't just for the user experience, it's absolutely critical for compliance. And this right here is where it all comes together. The system uses a technique called retrieval augmented generation, or RAG. It basically operates under a zero hallucination constraint. What that means is the AI is not allowed to guess. It's not allowed to make things up. It takes the hard data from that X-ray sensor and maps it directly to the specific text of Ontario Regulation 347, making sure its conclusions are legally and factually bulletproof. So the RAG engine confirms a contaminant. Now what? Well, the system doesn't just, send an email alert. It takes immediate, autonomous, and legally significant action all on its own. The very second the system confirms that contamination, it fires off an API call directly to the RPRA. That's the Resource Productivity and Recovery Authority's official registry. And with absolutely zero human intervention, it automatically generates a legal hazardous waste manifest. The data has instantly become a formal regulatory document. This brings us to the final, and I'd argue the most critical piece of this whole puzzle. How do you prove, beyond any shadow of a doubt, that every single step in this process was done correctly? Simple. You build a time machine. Yep, you heard that right. Internally, they call this system the time machine. It uses Vertex ML metadata to construct what's known as a cryptographic decision lineage. Think of it as an unchangeable, unbreakable chain of evidence that chronicles every single micro-decision the AI made along the way. And here's what makes it so powerful. Every final certificate isn't just a piece of paper. It is permanently fused to its own evidence. It's cryptographically locked to the exact AI model version that was used, the specific training data that was applied, and the precise sensor readings from the exact millisecond of validation. This creates a perfect auditable record that you just can't argue with later on. And that leaves us with one last thought to chew on. In a world where every automated action, every sensor reading, and every single algorithmic judgment is captured and sealed forever in an immutable record, what's left that can't be proven? It really makes you think, doesn't it? It fundamentally changes the entire nature of liability, compliance, and even trust itself.